n, and that's how you get the standard deviation.
Yeah. So I'm starting the broadcast. Smiling.
Sorry, I was talking.
The only problems that I had on the homework was the ones where it was like the probability is between this and this. But I guess you just figure out the two of them, then you probably subtract the
yeah,
difference.
that's exactly what
but
you
the
do.
thing is with
You can use the normal probability applet.
well, the ones that they've been giving us though, it's like you can plug it in. So it's like basically you just have to plug it in for one. And then
So the
for
applet.
Yeah, and then it's the same for the other because they're the same standard deviation.
Yeah, because recently they've been like the same standard deviation.
Like
away
if
from
guess
the
that's
mean
true.
is 10 and the standard deviation of 5, what is the possibility that it's in between 5? Well, the probability that it's in between, that it's, that first number is going to be the same probability as the second number because they're the same standard deviation away from it.
Okay, so it's practically the same thing.
Yeah,
There's-
and then then you can use that that rule that we know, that 98 whatever.
Yeah.
98.
Okay.
They could have found a more catchy name for it. 60, 95.
Yeah, be like,
yeah.
what should we name it? I got it.
Okay, so
Exactly.
so what is that formula then? So because it's like taking the number, like whatever number
Wait, what formula are we talking about now?
part 2, because they use the same formula.
Yeah,
on
you're
every-
talking about the more complicated z-score. Is that what you're talking about?
Yeah,
Yeah, so it's the mean, the number, whatever the observation number is, minus the mean, sigma, divided by the square root of n. The number,
well, it's the sample size.
It's the
so
sample
square root of the
size,
sample
yeah.
size.
and
then-
sigma, freaking A, why can't I remember what sigma
oh,
is?
the standard deviation.
The weird Q thing divided by standard deviation of n gets you the standard deviation. Gets Z. Z score from the sample mean.
Yeah,
Okay, so you take the number, you minus it by mu, or the mean.
Yeah.
So the number minus the mean divided by the standard
Standard
deviation
deviation
divided by the
divided by
square
the
root
square
of the
root
sample
of
size.
the sample size, yeah.
Okay.
Actually, so throw away everything that I just said about it being the same formula.
Well, not the standard deviation divided by the n. It's just the Q thing divided by.
So what is
standard-
sigma then? That's what we're trying to figure out. It's not the standard
No,
deviation.
it is the standard deviation.
Yeah, that's what gets you standard deviation.
Okay.
That little formula on the
So
bottom.
what standard deviation are we using to calculate a different standard deviation? Does that make sense?
Yeah.
Like if sigma is the standard deviation,
the
what
result
standard deviation are we trying to calculate?
Well, the result of this isn't the standard deviation; it's the Z score or a sample mean. That's what it
Z-score
says.
for sample mean.
Which
As
I don't
opposed
really-
to what are we normally getting
Yeah,
a
what are
Z-score
we
for?
normally
I
trying to
have
get?
no idea.
Yeah, so just like
Wait,
that,
no.
that
It's
distinction.
okay. So the z-score of the sample mean. I know because at the beginning of the problem, there was sorry, maybe it's because it's not normally distributed. Normally distributed, it says. Freaking, I don't know. Well, let's try the homework and see how it goes. Or maybe we should look up and just see what it says in the really quick. Maybe it'll tell us what life is about. Okay. Review of sampling distribution, probably involving example. Key concepts. But we want probabilities involving under a normal curve. Okay. And then this is any value of this random variable. If the sample mean is normally assumed, we can consider the sample mean x as an observation of the normally distributed mean and standard deviation of sigma over the number of compounds. With this in mind, we can complete the z-score for any value of this random variable. So as far as freaky, okay, let's keep. So now it's getting more complex. After finding the z-score, we can use the normal probability outcome. output to find the area under the curve. Suppose that the sample size of n has been drawn from a normal population of 7 and the standard deviation of, since the pair population, we know the sample distribution. I am finding the area under a normal curve. So the difference is oh, okay. So it's saying that this I'm a little confused about what the difference is between the two. Okay.
When we were doing the passage to standard deviation, that's all they called it. Called something else, but I guess we just go with it.
Yeah. I mean, as long as we know how to calculate it, I don't know.
As long as you remember the difference, like when they say standard deviation of the mean, you just remember that, this new formula.
So,
Or z-score, I mean.
yeah, z-score. Since the number of observations is larger than central with the which shows that the sample mean will follow distribution. Z-score for x equals this, okay, and then that's the mean. And then we're looking at the standard deviation. Okay, so they're finding the z-score. What the difference is. I don't know what the difference is, guys. I can't figure
I think it's just the difference in the title of what it's called.
What? So what? When would you use one and when would you use the other?
When they're asking for a z-score, you just use the one we learned in the beginning of the
Yeah,
class.
'cause, like the z-score.
And then when they say the z-score for a sample mean of a normal distribution, that's when you use this one.
So
I think it's just-
regular z-score is simple, and then z-score of sample mean, which obviously sounds more complicated, is more complicated.
Oh
I
yeah, it
assume
just
so.
adds the square root thing in there.
Yeah.
That's basically it though.
Oh wait,
It's just
that makes a little
it's
bit more
dividing
sense.
the denominator.
So what they're
by
saying
square root of
is
the sample size.
you need to find a new standard deviation based on the standard deviation that you already have. And that's why you have to do that whole sigma over the square root of the number of the sample size, because you're finding a new standard deviation, because they're asking you to find the z-score of a sample mean instead of just the z-score. That's why it's different. I don't know why that applies to life, but I know how to do it.
So we want to try the quiz, or we want to?
Let's do it. Let's get it done. I've never felt more prepared for this. Than
That means we're gonna
right
fail. Just kidding.
now. Okay.
No, it's still going.
just
You're
edit out some
killing
parts.
me. Are we gonna go for it?
Let's do it.
I already started.
Wait, are you doing the broadcast while we do it?
So I did last time too. I don't know if it makes a difference.
I don't really. I don't care.
I actively participate in this group meeting. That should be obvious.
Heck yeah, I'm so actively participating. Sorry, I'm almost there. I just clicked on the group participation thing. 2 attempts. It's on.
Yeah, we've never had to use the book. I'm assuming these are closed books, right?
I would think so.
Because they never mentioned, like, because they always mention it on the other one. But they
I'm
never mention it on this
assuming
one.
we can, since it's a quiz, assuming we probably use whatever. I don't know.
Oh, yeah, I don't know. I just assume that if they want you to take it without notes, then go repeat your answers and then
Yeah.
go back.
I don't really know.
So I think
I don't
so.
really
'Cause the
care.
homework one looked like it was open.
Because they always say it. Okay, using the normal probability applet.
Okay.
Using the normal probability applet to find the combined area under the standard normal curve that is to the right of the z, the left of z, whatever.
Literally, all you do is just plug in the number and then find it. 1.358. And so it's saying that is right of z and left of that. So area is 1.745. That's what I got.
Right of.
So it says to the right and to the left. So literally just that. Just this.
1.35. Yeah, I'm just gonna plug it in.
Yeah, I got 0.17.
So it's both.
Yeah, so it says both.
To the right of
And
to the left of. So yeah, that's you got.
I got 0.1745.
Is it to the nearest 3 though?
Yeah.
Oh yeah, you're right. So it would be 0.175. Sorry, I always forget about that.
Which of the following will have a smaller standard deviation?
If 9 observations are randomly drawn from the population, the distribution of the individual observation.
Whoa.
Wait, this doesn't make
What
any
is this
sense.
asking?
I don't even know. This doesn't make. Okay.
Wait, that's question. Oh, because we have the first 2 questions. Okay,
which
so
of the following will have a smaller deviation if 9 observations are randomly drawn from the population? So the distribution of the sample means this cannot be determined. I don't think it can be determined.
well, okay, so the distribution of individual observations is like because we know that the more observations you have, like the more accurate it becomes, like the smaller standard deviation because it's getting closer to the mean. So it's like I'm just wondering if the distribution of the sample means is the correct one because it's like.
I think you might be right actually, because that would make sense.
Because like individual observations makes it sound in my mind like they're just like doing one at a time, but I don't know if that's completely true because it doesn't feel like.
I think we should answer
exactly
that because that makes a little bit of sense, and if not, I think it's just can't be determined.
But what do you think?
I have no idea. That question is super vague. It seems like.
I feel like it's vague on purpose.
Well, because we've been talking about sample means for a while now, though.
Yeah, what you say makes sense though.
If it's
could try
right,
it, yeah.
if I'm understanding
Results
it right, I
imply
just don't know if I am.
That the spread in number decreases as the sample size increases.
That's the shape then. So that'd be the central limit theorem, wouldn't it?
The spread decreases as the sample size decreases.
Yeah, because it's not talking about
did it
accuracy.
say shape?
The
What is spread?
The spread is the shape.
Like yeah, how
Spread
far
is
they
the
are
shape
apart.
for sure.
How far the dots are, so it holds it. further.
Yeah, because it's like if you have one clear over here, it's right skewed.
So the spread is the shape. Okay, cool. Scores on the quantitative portion, whatever. Mean is 150.8.
So yeah, we should probably just remember that whole formula here real quick. So we were saying, so it's the number
Minus the mean over sigma, which is the standard deviation, divided by the square root of the sample size. But in this case,
I don't know if it's.
I don't know
if it's
if
asking
we
for that. I just want to make sure we
one or
have
the
that.
other. I'm not sure.
Well, it's talking about. Okay, so she.
So Diana earned a score
The
of
Z
160.
score.
What is the Z score corresponding? I think it's just normal on that one. So I think it would be the 160 minus 150.8 divided by 8.8. Because it's not asking us the
Responding to the
sample means. It's just asking the normal Z score. So I think that would be the case. But however, let's keep looking. And I'm just curious if
Later on, it asks for the Z score the sample means.
yeah. So these two are going to be just the normal. You would take
That would be making things really complicated.
158. Oh, sorry, it's 158 what?
150.8.
So 150.8 minus 160
The z-score
equals
corresponding to her score.
divided by.
So we're taking 160 minus the mean. Is there a mean? Oh yeah, the mean is.
The mean is 150.8. I got negative 1.045, which would be negative 1.05.
Well, it should be a decimal though, because that's what they're asking for the answer. If the answer is
I think it's because
0.8976,
you subtracted the 150 minus the 160. So you did it like the other way.
Did I? So
Yeah.
I know it's the number. Oh, yeah. So it'd be 160 minus 150.8, and then you divide it by.
what was the sample size?
I still got 1.05.
Do they
That's
give
the
us?
problem. They don't give
It
us
doesn't give us the
size.
sample size, so this has got to be the normal one.
Yeah, but,
Yeah, no, this is right.
but you need the sample
This
size.
is right. They're asking us.
because you need to divide the
Hey,
bottom by something.
Hold on a second. They're asking a z-score. These are z-scores, right? So 1.05 would be right. Because if you plug it in right here,
There's no way that's right though. 'cause-
yeah, it is.
But just like for the format that they're giving for the answer, like that's always they want. Like
What do you mean?
because they say that if the answer is 0.8976, then you'd enter 0.89.
I think they're just messing with you. I'm almost 100% on this.
How do you get a z-score without the sample size of the population?
So they're not
Do we
asking
need
for they're not, so this is the thing. Remember what we were talking about? Formula is just number minus the mean over the standard deviation. This formula
No.
is the number minus the mean over sigma divided by the square root.
Pretty sure there's still something you divide by. It's just not. You just don't have the square root.
No, I'm pretty positive on this one. I think there's a different answer, but I'm pretty sure.
Well, it's just like the end thing though is like it's always or like when they give the answer in the decimal place, like throughout the whole course so far, it's always been like a decimal place one. So
Okay.
that just
Do you have a better solution?
I'm just trying to figure out like
Okay.
what the other thing is dividing by.
Okay. Well, they literally give us no other numbers, so there's no other way we could do it.
Let's see the scores. In the corner.
What do you think, Seth?
I know it's a different formula. I don't remember what it was though.
What is a person? This problem that random select the score would be this. So, what you want to do?
Just to get the answer, you're basically taking 9.2 divided by
8.8,
8.8, which is giving you the 1.1.
1.05.
So those are the only three numbers we have.
So this is my thought
But is
process
that-
behind it, Bruce. We're doing this based off of what we've learned, right?
Mhm.
So in the homework, we only use two equations. This equation that I just explained to you, and the other one. So would it make sense that they do any other one?
Yeah, I'm just wondering if there's something, or like if we're dividing by the right thing, because it's like it should give us a number that's less than 1.
Why?
Or just because of
So
the
so
format
this
of
is
the
the
answer.
reason why I think it makes sense is because when we did the z-score or whatever, when we were doing one of these other problems, it's totally normal to have a z-score of 1.
So
You're
is it
mixing
asking
up.
for probability then?
No, they're not asking for probability. You're mixing them up. So area, the full area is 1, right?
Mhm.
So I don't really know, but you put in 1.05 right there and it doesn't look like a crazy thing. So I don't know
Yeah,
why that
'cause-
wouldn't be right.
Because I just wonder if this is an algebraic problem. Because I think because we're probably solving for the sample size and then plugging that back in to find the z-score. Because it seems like out of 10.
Well, we do have 2 chances to get it right. Why don't we just
Well,
not waste our time trying to figure it out if it's not?
well, because
wrong.
we're gonna have to figure it out either way, though.
Well, I know, but if I'm right, then we won't.
That's true.
What was the number that you got?
I got 1.05. So Diana earned a score of 160. What is the score corresponding
Do you have a pen?
to
I don't.
Diana's? Yeah, no, that's right.
Because I'm wondering if this is an algebraic problem, because they were, I don't know if that was part of this chapter or the last one, but they did something with solving things for x, because it's like because yeah, so you have the 160 minus the 150.8 and then divided by, because I felt like there really was something else you still divided by, but like in the more complex z-score, you divided by the square root of something.
So what
But
you're
in this
saying
one
is plug it into the complicated formula and then solve for n?
Yeah,
It's 8.8 divided by the square
But they're
root
not
of-
asking us to
or it'd
solve
just
for
be
n.
x or whatever.
Yeah.
They're not asking us what the sample mean is.
So
They're
like,
asking us what the z-score is. So once again, like we had that problem before, remember? Where we were trying to solve that problem and you had two variables.
yeah.
If you have two variables, you can't solve an equation.
Yeah, I'm just trying to figure this out. So
Okay.
Yeah.
You're fine.
16.
I mean, I'm cool if you guys want to like move on to the other questions and then come back. I just feel like we're wasting a lot of time. Because
Yeah.
there's only two questions that ask it that way. I mean, we could get those wrong and still get an 80 on the quiz. I mean, obviously, I'd want to get them right, but I just feel like to solve an equation with two variables be like pounding your head against a brick wall until you figure it out. And I mean, maybe you will after like 30 minutes, but you could be almost done with the quiz by then.
What we could see is, so the 150, that's going to be right in the middle, you know?
Mhm.
And then you add 8.8 to get, you know, the area for the 68%.
Mhm.
That goes up to 159.6, and she scored a 160, so she scored 0.4 higher than that. And so if you go on this chart,
Wait, are you talking about number 7 or are you still on number 6?
I'm on the same one. So if you go, because this is the mean, she scored a little bit further out than 0.1 or than 1. And his number, the 1.05, is barely outside of the 1.
So it could be right, or
It could be. You see what I'm saying?
as far as the z-score, so
Because the mean is this, and then you add the standard deviation of 8.8 to that, and you get the 159.6, and she scored a 160, which is because the 159.6 is this one, because that's one out.
oh yeah.
And then her score is barely above it, which that number is.
Would be barely above it. So the z-score is basically how many standard deviations
And I guess
it is away from the mean.
the z-score can be above 1, or like obviously.
Well, I guess when you look at the normal probability applet, if it was here, it would technically be 3, right?
Yeah.
So it's the z-score, I think where we're mixing things up is that the area can't be over 1, but the z-score can.
Yeah. Well, what's throwing me off is just like the format that they're asking for it in. But I mean, like we can go with the 1, because the z-score can be above 1.
That is weird though why they do tell you to convert it.
Because it might be wrong. Just
What do you mean they
by
asked you to convert it?
Because they only have decimals after, they don't have a 1 in front.
Yeah, I don't think they're like
Why-
giving you a hint as to what the
They
answer
might
is.
be, because I remember 2 lessons ago they were doing that.
Because yeah, it's like been every like everything so far like is like that. So I mean, I think it's like either we've got the formula right or we've got the formula wrong. But if we need to go back and correct this, then we can just go look up the formula for the z-score and figure that out, you know?
Sure.
But I think it really does come down to just, do we have the formula for the z-score right? All the numbers that we can have, and so unless there's an algebraic way to get around and figure stuff out, then it's like Except that
Yeah, I just feel like so far everything's been pretty cut and dry. Whenever we do an algebraic thing, there's always only one variable. If they're not asking us to find like an approximate number. If we had two variables, maybe we could find like close to it, but they're asking us to find exactly what it is. With two variables, there's no way you can do that.
no, I know. Yeah, I know. So it's like there's, yeah. So it's like either we have the formula right. Well, I mean, there's no way the things in the numerator change, right?
160. So
Because that's
sorry,
probably right.
what is
and
the
there's only one option for the denominator.
probability? So the probability and the area are the same, right? So what I did for number 7 is I just used exactly what we already had. This is 160, right? And so I just highlighted the portion that was after 160. And I got the area, and the area is the probability.
I mean, for this, you could maybe add 2 more numbers because remember in the homework there, or the preparation assignment, they're saying what's the probability of it being between this number and this number. You could add those 2 numbers because that's the mean. So you could add this to that and then subtract it by that, so we get the 2 numbers on each side. See what I'm saying? Maybe they want us to do that because in the homework they were giving us between this and this. I don't know if that would help.
So what would you do? So you'd take.
Well, I would think you to this and then also subtract it to get the.
Oh,
other side.
because you're getting the standard deviation of.
Because
or like.
Because that would give you what's on both sides.
But you can't have 158. Like if you add, or is that 15? Yeah. So if you add, so you're saying like you put it in on one side at 158.
It'd be 159.6, and then like
but that seems unusual as well
does.
Because
I just don't. I mean, I guess we'll just go with what we have.
Yeah, because I think we just have to. That's one we have to just go figure out.
So it looks like on number 8, it's basically just asking you to find the mean and the standard deviation.
What is the probability of a randomly selected score above 160 on the quantitative portion of the GRE?
So it's just not giving you as many normally would. And so just like plug in those numbers in the Excel and find the standard deviation and the mean.
Yeah, if we get one wrong on these, they're all wrong.
Yeah. But yeah, and that's what's annoying.
Of 160 on the quantitative portion.
Oh, you're still on that?
Yeah. So that's above 160, so that's 148.
No, I got 0.147. The area is when you shade what's after that point.
What did you get for? What did you put for point or question 6?
Because what question? When you put in the z-score, right? I guess that's what the question is. Because I think what I had like 1.048, remember? But I'm not sure if they want you to put in the rounded z-score here or the original z-score.
Well, the z-score, did you not get? Because when you take 9.2, right, divided by 8.8, I got 1.045. And
yeah, that's what I'm
rounding to the nearest or 3 decimal places.
So that's where I got 1.05.
No, it'd be 1.045 because.
Oh yeah, you're right.
Because you're rounding all
you're
3,
right.
And so that would make that answer slightly different.
I forgot not the second decimal place, but the 3rd decimal place. So yeah, that would make it different. You're right. 0.45. Then it would make it 0.148. You're right.
Yeah. A random sample of 5 students was selected to take the GRE. Their scores are this.
Yeah. So, like I was saying before, I think literally they're just not giving us the mean and the standard deviation, and they're expecting us to find those ourselves based on the.
Well, they give us the information above question 6. That still applies to this one.
Wait, is it still the same?
Yeah.
Oh, it's still the same.
Yeah, that'll still apply.
What is the z-score? to the sample mean of these student scores.
So we have the mean, we have the standard deviation.
Wait. What is the z-score
We have the
corresponding?
sample size. We have the
mean
numbers.
of these
So
scores.
we have none.
Okay, yeah. I would just mixing them out. So the mean is 150.8 and the standard deviation is 8.8. So the equation is that new one that we're looking for, which is the number minus the mean divided by the standard deviation divided by the square root of the number of the sample size.
Okay, so we know it's something minus 150.8.
The only thing that I'm a little confused about is normally it selects something, right? So instead of just giving us like 5 numbers, they say,
well, because it's probably just gonna, like, what we can do is we can find a mean of that, because we're just trying to, because they don't give us the mean in that question, but you just take those numbers and then you take the average of it and then you have a mean.
I think that that Seth is right though. It corresponds to the same problem. Like all of this is the same.
Yeah, because they say
so it says
next
4 questions. So the mean is still
150.
150.8 and the standard deviation is still 8.8.
So these should equal 150.8 though, right?
What do you mean?
Because this is a different sample size though.
Well, yeah, but you would still use the same.
Not if it's.
No, you would.
Well, but if you have a different sample size, you have a different mean.
Well,
because that's the whole point of.
We're not trying to find a different mean. We're trying to find the z-score of the sample mean or whatever.
Because the mean of this is 160. It's not the same as the one above. If we're taking a sample size of 5 instead of a sample size of whatever we had before.
So based on your logic, what is the number that we're using for x?
What is this?
Frick. Do either of you guys have a pen?
Just this one. That's hers.
Smooth. All right. Well, I guess one of us will write down the equation. A random sample of 5 students was selected to take a geometry of their scores. What is the z-score corresponding to the sample mean of these students?
These are a lot different than the homework ones.
Yeah.
Yeah.
In the homework ones, they gave us a specific number.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So what was the mean that you got?
It was 160. So I mean, if
which is mu, whatever.
Is it? The standard deviation is still the same, right?
I would hope so.
What is the z-score? Oh, okay. Well, this is asking. So if the sample mean is now 160, that's what we put into the spot right here, and then we subtract that. By
that's right. We do the sample mean minus the original mean. Is that what you're saying?
Yeah.
150.8.
So this is actually.
And then you divide it by.
Now we have
the standard deviation.
We have
the old standard deviation divided by the number, which is 1, 2, 3, 4, 5. The square root of 5.
So it's 8. Or is that what the standard deviation was? Was 8.8?
8.8 is the standard deviation, and you divide it by the square root of 5.
Yeah, so I mean that should be the problem, right?
Yeah, that is.
Yeah,
that makes sense. The only thing that was confusing me was the x, and that makes sense. You found a new mean, which is x.
Yeah.
So by the square root of 5 by 8.8.
Yeah, it's supposed to be. I don't think I can do it on my phone. No, can you? You do square root?
You can.
I don't know how. You putting it in Excel?
Yeah, I just do everything in Excel. Square root of 5.
Like 2.236.
2.33.
What did you get?
Let's see.
Because it's 160 minus 150.8, right?
Yeah. What'd you
Just
get for the square root
9.2.
of 5?
I got 2.23606.
Okay, yes, that's what I got.
Okay, so what's the answer?
And then it's 8.8 divided by 2.23, which gives you 3.9354.
Wait, are you rounding any of the intermediate calculations?
No, I'm not rounding.
Okay. So what did you get?
I got 2.337.
2.
Well, I guess it'd be 2.338.
Oh, yeah. Okay. So now, what is
So I
the-
guess we have a chance of being right with the one above, because like this is also asking you to round it to the decimal places, but if we're finding another z-score, then it's going to be above.
Yeah, well, I guess
So
we'll know when
might
we
be right.
finish the problem. We'll know for future reference
Or
if that's actually applies to the answer or not.
otherwise, like all these are wrong.
Yeah, then we get like a 20%.
I know.
Yeah.
What's the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
So the z-score,
So what's the probability? So we're just going to take that z-score and
plug it in,
So
which
it's
was, what was it?
2.338.
And then you just say the probability they will have a mean achieved greater. So that would be
That's really small.
0.009. But it would be 0.00. Frick. What would you do? Would you round that to 10?
Yeah,
So it would be 0.01.
0.
0.01.
It's like 1%.
It's not very high probability.
Okay. Almost there. Suppose the mean GPA of BYU students is 3.5 and the standard deviation is point.
Wait a minute, that one said round to 4 decimals.
Oh, did it?
Yep,
Where?
in the question. So it'd just be that.
Oh, yeah. Okay. That's probably why they
So
said to
it's a
do
good
that.
sign.
Because they knew that it would not be.
Why
able
would
to
you
round
change
it
it on every problem?
So,
Suppose that the mean GPA is 3.5. Is left skewed.
a random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random sample, which represents the sample mean who are selected? So they're saying that there
It's
was
approximately
81, so
normal.
it would still be normal because
Yeah.
it's large, right?
It's like the only thing you need to know for this class.
It's approximately normal.
It's over 30.
What is the mean distribution of sample means for all possible samples of size 81 that can be drawn from the parent population? Wait, what? What is the mean distribution of the sample means for all possible sample sizes? Is that the z-score again?
No, you're on 1 decimal.
Is that the z-score? No. What is the mean distribution of? So it's asking us to find the mean. So what's going on is they so we have to find certain things and then now here's where your algebraic crap comes in because they're wanting us to solve for the mean once we know other things. Does that make sense?
What is
Sorry, I'm
Your
messing
algebra
crap.
crap.
next 5 questions? Okay, so
So what is the mean distribution of sample means for all possible sample sizes of size 8 that could be drawn from the parent population? So, so that's for that question too? Oh, yeah. Okay, so we'll take what we already have, right? The, I guess we take the z-score